increment I plus 1. So we are going to increment from I, it becomes I plus 1, 1 plus 1, it becomes 2. So we call backtrack, size is 1, k is 2, it doesn't do anything. We come inside the for loop and we add 3, because now I is 2 and the value at I is 3. So we add 1 and 3. And again we remove the placeholder last element. And we check. Now it becomes 3. I becomes 3. It is not less than 3. So it comes out of the for loop. But we are again inside the first for loop, inside the backtrack. So we're going to again remove this one as well. So we'll get a clean slate. So after we get a clean slate, now I is incremented. Initially it was 0, which called the backtrack. Then 1 called it. We completed all the possible with ones. And now we incremented the I to 2, the second element. We incremented I plus 1. And now again we will use the backtrack. The placeholder dot size is still 1, but the k is 2. We're going to again call backtrack, come inside the for loop. We'll add 3 and then it satisfies, and we'll add 2, 3 to the output here. And finally, when k is 3, it's going to call 3 times. This for loop is going to spawn 3 more for loops recursively, because we are recursively calling backtrack. And finally we will add 1, 2 and 3 to the output. So this is the implementation of subsets, generating subsets with a given set. I'm going to just write the pseudocode in my next video without the analysis of the call stack. This was just for a deeper understanding the mechanism of backtracking and iterative recursion. And since every time we are exponentially increasing the number of for loops, the worst case this is going to run is in 2 power n, an exponential time complexity, plus the original, the main for loop, which is calling, this runs in an order of n. So this is going to be an n dot 2 power n. Or we can ignore the non-dominant term n. So this runs in a time complexity of an exponential time complexity. Because for every k, we're going to exponentially iterate recursively calling the backtrack function. The backtrack will call itself exponentially. I hope everyone enjoys this video. We'll look at the plain pseudocode in my next video. But this is the foundation. This is the categorical substrate, the foundation of understanding the analysis of the call stack. Once we understand this, writing the pseudocode is going to be very easy. Thank you so much, my friends, for watching.